Jai Hind everyone. In this video, we'll cover Chapter 2 of NCERT Class 11 Physical Geography, that is the origin and evolution of the Earth. So in this video, we'll study about some theories related to origin of the Earth and also origin of the universe. And then we'll study different topics like formation of stars, formation of planets, and also evolution of the Earth, evolution of lithosphere, evolution of atmosphere and hydrosphere, and the last topic is origin of life. So let's get started. So we'll start with origin of the Earth. A number of hypotheses were put forth by different philosophers and scientists regarding the origin of the Earth. One of the earlier and popular arguments was by German philosopher Immanuel Kant. Mathematician Laplace revised it in 1796. So the argument given by Immanuel Kant was revised by mathematician Laplace, and he has given it a name called nebular hypothesis. So nebular hypothesis was attributed to Laplace, who gave it in 1796. We'll see what the nebular hypothesis is. So the hypothesis considered that the planets were formed out of a cloud of material associated with a youthful sun which was slowly rotating. So this is what nebular hypothesis states, given by Laplace, that is, planets were formed out of a cloud of material associated with youthful sun which was slowly rotating. In 1950, Otto Schmidt in Russia and Carl Weizsäcker in Germany somewhat revised the nebular hypothesis, though differing in details. They considered that the Sun was surrounded by solar nebula containing mostly the hydrogen and helium, along with what may be termed as dust. The friction collision of particles led to the formation of a disc-shaped cloud, and planets were formed through the process of accretion. So we'll see what Schmidt and Call was saying in this revised nebular hypothesis. So earlier it was told that the planets were formed out of cloud of material associated with youthful sun. But in 1950, given that the sun was surrounded by solar nebula, which has mostly hydrogen, helium, and also dust. These particles and the gases, they led to formation of a disc-shaped cloud because of friction and their collision, and the planets were formed through the process of accretion. What is the meaning of accretion? It is the growth or increase in an object by adding new layers. So firstly, the solar nebula had hydrogen and helium and dust, and then friction and collision of these particles led to formation of disc-shaped cloud, and then planets were formed through the process of accretion. So this is what the nebular hypothesis contained in 1950. However, scientists in later period took up the problems of origin of universe rather than that of just the earth or the planets. So now we'll see the theories that are related to the origin of the universe. The most popular argument regarding the origin of the universe is the Big Bang theory. It is also called expanding universe theory. Edwin Hubble in 1920 provided evidence that the universe is expanding. So who has given the Big Bang theory? It was given by Edwin Hubble in 1920. As the time passes, galaxies move further and further apart. Now we'll try to understand the Big Bang theory with an example. So let's say we have a balloon and we marked 2 points. We made 2 points on the balloon. Once we start blowing air into the balloon, and when the balloon starts getting inflated, we can observe 2 things. One is the distance between the 2 points will increase as we blow more air into the balloon. And also the second point is the points themselves also keep on increasing. So this is what the basic thing that need to be put in mind to understand the Big Bang theory. Take a balloon and mark some points on it to represent galaxies. Now, if you start inflating the balloon, the points marked on the balloon will appear to be moving away from each other as the balloon expands. Similarly, the distance between the galaxies is also found to be increasing, and thereby the universe is considered to be expanding. However, you will find that besides the increase in the distances between the points on the balloon, the points themselves are also expanding. This is not in accordance with the fact. Scientists believe that though the space between the galaxies is increasing, observations do not support the expansion of galaxies. So the balloon example is only partially correct. So from that, the scientists concluded that although the distance between the points is increasing, but there is no such evidence that the points themselves or the galaxies themselves are expanding. So in this balloon experiment, only the distance between the points is correct and not the expansion of points. Now we'll see what the Big Bang theory says. The Big Bang theory considers the following stages in the development of the universe. At a point zero, or in the beginning, all matter forming the universe existed in one place in the form of a tiny ball, or we can call it as a singular atom or a point with an, if you see, this is the point, or see, this is the point of singularity where it has unimaginably small volume, infinite temperature, and infinite density. So at this point, the singularity had very, very small, negligible volume, but infinite temperature and infinite density. At the Big Bang, the tiny ball exploded violently. What happened? At the time of Big Bang, this singularity had exploded violently. This led to a huge expansion. It is now generally accepted that the event of Big Bang took place 13.7 billion years before the present. So when did the Big Bang take place? It has taken place 13.7 billion years before the present. But the expansion continues even to the present day. As it grew, some energy was converted into matter. There was particularly rapid expansion within fractions of a second after the bang. So 13.7 billion years ago, when the Big Bang has taken place, within a second of the explosion, there was a rapid expansion. Thereafter, the expansion has slowed down. But within first 3 minutes from the Big Bang event, the first atom began to form. So when did the first atom began to form? It was within 3 minutes from the Big Bang event. Next, within 300,000 years from the Big Bang, temperature dropped to 4,500 Kelvin. So what happened? Within 300,000 years from the Big Bang event, the temperature also started decreasing and it has dropped to 4,500 Kelvin. And this decrease in temperature gave rise to atomic matter, and also the universe became transparent. So what are the conclusions from the Big Bang theory? At the beginning, there was a tiny ball, or we call as singularity, had unimaginably small volume, infinite temperature, infinite density. But around 13.7 billion years ago, the Big Bang has taken place where the tiny ball had exploded violently. Within a second of Big Bang event, there was a rapid expansion, and thereafter the expansion slowed down. And within first 3 minutes from the Big Bang event, the first atomic matter, first atom began to form. And the next one, within 300,000 years from the Big Bang event, temperature dropped to 4,500 Kelvin, and this gave rise to atomic matter, and also the universe became transparent. The expansion of universe means increase in space between the galaxies. So here, as it is called expanding universe theory, the expansion of universe means increase in space between the galaxies, but not the expansion of galaxies themselves. An alternative to this was Hoyle's concept of steady state. So this Hoyle's concept of steady state is an opposite view to the Big Bang theory. So in Big Bang theory, we learned that the universe is expanding, but Hoyle's concept of steady state gives a different view. It considered that the universe to be roughly the same at any point of time. So the Hoyle's concept of steady state says that the universe is roughly same at any point of time. However, with greater evidence becoming available about the expanding universe, scientific community at present favors argument of expanding universe. So with new information and with the new evidences, scientists started considering argument of expanding universe, and they preferred it to Hoyle's concept of steady state. So this is about Big Bang theory, which talks about the origin of the universe. And the next topic is the star formation. In the universe, the distribution of matter and energy was not even. These initial density differences gave rise to differences in gravitational forces, and it caused the matter to get drawn together. These form the basis for development of galaxies. So what was the basis for development of galaxies? In the universe, the distribution of matter and energy was uneven. So this uneven or indifferent density differences gave rise to differences in gravitational forces, and it also caused the matter to get drawn together. A galaxy contains a large number of stars. Galaxies spread over vast distances that are measured in light years. So how are galaxies measured? They are measured in light years. The diameters of individual, before that we'll see what a light year is. A light year is a measure of distance and not of time. So as we heard the year in light year, we may think of it as a measure of time, but no. But a light year is a measure of distance. It actually measures the distance that the light travels in 1 year. So light travels at the speed of 3 into 10 to the power 8 meter per second, as we know. Considering this, the distances that the light will travel in 1 year is taken to be 1 light year. This equals to 9.461 into 10 to the power 12 kilometer. So what is the distance a light travels in 1 year? That is 9.461 into 10 to the power 12 kilometers. And the mean distance between the sun and the earth is roughly 149,598,000 kilometers. But in terms of light years, it is 8.311 minutes. So what is the light year between sun and earth? It is 8.311 minutes. So this is about a light year. Next, the diameters of individual galaxies range from 80,000 to 150,000 light years. A galaxy starts to form by accumulation of hydrogen gas in the form of a very large cloud called nebula. So what is a nebula? It is a very large cloud that has hydrogen gas got accumulated in it. Eventually, growing nebula develops localized clumps of gas. These clumps continue to grow into even denser gaseous bodies, giving rise to formation of stars. So when the nebula starts getting developed with localized clumps of gas, these clumps continue to grow and they become denser gaseous bodies, and they give rise to stars. The formation of stars is believed to have taken place some 5 to 6 billion years ago. So the Big Bang theory has taken place 13.7 billion years ago, and the formation of stars has taken place around 5 to 6 billion years ago. And the next is formation of planets. The following are considered to be the stages in the development of planets. The stars are localized clumps of gas within a nebula. The gravitational force within the lumps lead to the formation of a core to the gas cloud, and a huge rotating disk of gas and dust develops around the gas core. So, the stars are localized clumps of gas within a nebula, as we studied in the previous topic. The gravitational force within lumps of gas leads to formation. These get accumulated and these become the core of a gas cloud. And then a huge rotating disk of gas and dust develops around the gas core. So this is the meaning of first point. Now let's see the next one. In the next stage, the gas cloud starts getting condensed and the matter around the core develops into small rounded objects. So in the next stage, so this is the gas cloud and matter around the cloud, these small rounded objects. These are the small rounded objects. These small rounded objects, by the process of cohesion, develop into what is called planetesimals. So these smaller rounded objects, they start getting developed by cohesion. Cohesion means force of attraction between particles. So with this process, they get developed and they are called planetesimals. Larger bodies start forming by collision, and gravitational attraction causes the material to stick together. So after the planetesimals are formed, then larger bodies start forming by collision, and gravitational attraction causes the material to stick together. Planetesimals are a large number of smaller bodies. And in the final stage, these large number of small planetesimals accrete to form a few or larger bodies in the form of planets. So in this, these small particles, they again get combined to form a bigger body called a planet. So what is a planet? It is the formation of smaller rounded objects called planetesimals by the process of accretion to form a larger body called planet. So this is how planets are formed. And the next topic is evolution of the Earth. Do you know that the planet Earth initially was a barren, rocky and hot object with a thin atmosphere of hydrogen and helium? This is far from the present day picture of the Earth. What is the present day picture? The planet has ample amount of water and conducive atmosphere favoring the existence of life. But this wasn't the same when initially, where the planet Earth was a barren, rocky and hot object with a thin atmosphere of hydrogen and helium. Between 4,600 million years and the present led to the evolution of life on the surface of the Earth. So when was the evolution of life on the surface of the Earth has taken place? Between 4,600 million years and present. The Earth has a layered structure. If we see the diagram here, this is the layers of the Earth. The first one is the crust, and the next one is mantle, and the next one is core. The Earth has a layered structure. From the outermost end of the atmosphere to the center of the Earth, the material that exists is not uniform. The atmospheric matter has the least density. From the surface to deeper depths, the Earth's interior has different zones, and each of these contains material with different characteristics. So here it is saying, oh no, let's continue with the next topic because we get it in the middle. Evolution of lithosphere. The Earth was mostly in a volatile state during its primordial stage. So initially the Earth was mostly in a volatile state. Due to gradual increase in density, the temperature inside has increased. As a result, the material inside started getting separated depending on their densities. So due to the increase in density and the increase in temperature, the material inside the Earth started getting separated depending on their densities. This allowed heavier materials to sink down and lighter materials to move towards the surface. So if you see the structure of the Earth here, the crust is the topmost layer and core is the innermost layer. So from this we can say that as we move from surface to the center of the Earth, the density increases. So the crust has less density compared to the core. With passage of time, it cooled further and solidified and condensed into a smaller size. This later led to the development of outer surface in the form of a crust. During the formation of Moon and due to the giant impact, the Earth was further heated up, and it is through the process of differentiation that the Earth forming material got separated into different layers. So this material, although they sink down and they have come up to the surface of the Earth, but due to the formation of Moon and due to its impact, the heat that because of that heat that the Earth was further heated up during the formation of the Moon, and through the process of differentiation, the Earth forming material got separated into different materials. Starting from the surface of the central parts, we have layers like crust, mantle, outer core and inner core. From the crust to the core, the density of the material increases. The next one is evolution of atmosphere and hydrosphere. The present composition of Earth's atmosphere is chiefly contributed by nitrogen and oxygen as we know it. There are three stages in the evolution of present atmosphere. So it was in three stages that the atmosphere of the Earth has been evolved. The first stage is marked by loss of primordial atmosphere. In the second stage, the hot interior of the Earth contributed to the evolution of atmosphere. And the third one is Earth was modified by the living world through the process of photosynthesis. So these are the three stages, that is loss of primordial atmosphere, and the second one is through Earth's hot Earth's interior, which helped in evolution of atmosphere. And the third one is atmosphere's composition was modified through process of photosynthesis. The early atmosphere with hydrogen and helium. So loss of primordial atmosphere. What does primordial atmosphere included? That is hydrogen and helium. How are they removed? They have been removed as a result of solar winds. So it is not only in the case of Earth, but also in other planets also the primordial atmosphere was stripped off as a result of the solar winds. This happened not only in the case of the Earth, but also in all the terrestrial planets, which were supposed to have lost their primordial atmosphere through the impact of solar winds. And next, during the cooling of the Earth, gases and water vapor were released from the interior of the solid Earth. This started evolution of present atmosphere. So what was the second stage? It was due to hot Earth's interior. So what did it happen? What happened here? So here, the gases and water vapor from interior of the Earth were released into the atmosphere. This started the evolution of present atmosphere. The early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little of free oxygen. The process through which the gases were outpoured from the interior is called degassing. So how did the gases from interior of the Earth reach atmosphere? It is by the process called degassing. Continuous volcanic eruptions contributed water vapor and gases to the atmosphere. As the Earth cooled, the water vapor released started getting condensed. So as the temperature getting decreased, the water vapor released started getting condensed. The carbon dioxide in the atmosphere got dissolved in rainwater, and also the temperature further decreased, causing more condensation and more rains. So what happens when it rains? The rainwater falling onto the surface got collected in the depressions to give rise to oceans. So when did the formation of oceans takes place? The Earth's oceans were formed within 500 million years from the formation of the Earth. So we can say that oceans are 500 million years younger than the Earth. This tells us that the oceans are as old as 4,000 million years. Sometime around 3,800 million years ago, life began to evolve. Although the oceans were formed around 4,000 million years ago, but life began to evolve only around 3,800 million years ago. However, around 2,500 to 3,000 million years before the present, the process of photosynthesis got evolved. So the evolution of photosynthesis took place around 2,500 to 3,000 million years ago from the present. Life was confined to oceans for a long time. Oceans began to have contribution of oxygen through the process of photosynthesis. So first oceans got affluent with oxygen through the process of photosynthesis, and life was confined to oceans for a long time because there was little oxygen on the surface of the Earth, and oxygen is essential for life on the Earth. Eventually, oceans were saturated with oxygen, and 2,000 million years ago, oxygen began to flood the atmosphere. So after the saturation of oceans with oxygen, the oxygen began to flood the atmosphere around 2,000 million years ago. And in origin of life, the last phase in the evolution of the Earth relates the origin and evolution of life. It is undoubtedly clear that initially the Earth or even the atmosphere of the Earth was not conducive for the development of life, because we know how the Earth was a barren rocky structure and there was an atmosphere that would not support the evolution of life on the Earth. Modern scientists refer to the origin of life as a kind of chemical reaction which first generated complex organic molecules and assembled them. This assemblage was such that they could duplicate themselves, converting inanimate matter into living substance. The record of life that existed on this planet in different periods is found in the form of fossils. So that is why fossils are very important to study the evolution of life on the earth. The microscopic structures closely related to the present form of blue algae have been found in geological formations much older than 3000 million years. So blue algae or the microorganisms as blue algae they were as old as 3000 million years. It is assumed that life began to evolve sometime 3800 million years ago. So it can be said that the life began to evolve sometime around 3800 million years ago. So this is all about the chapter 2 of NCERT class 11th physical geography, that is the origin and the evolution of the earth. Please do like the video and share it if you think it is beneficial, and we'll meet in the next class. Jai Hind.